guys, welcome back to my channel, and today we will be looking at Collatz conjecture. Okay, so let us quickly look at the rules of this algorithm. So this is an iterative algorithm that says given an input n, which is any positive number, what you have to repeatedly do keep doing is, if your n is even, then you will replace n by n by 2. Okay, and if your n is an odd number, then what you have to do, you have to replace n by 3 times n plus 1, and you have to keep on doing this till you reach 1. Why is that? Let us see an example of that. Okay, suppose our n is 5. Okay, now as 5 is odd, which is odd, so we will replace n by 3 times 5 plus 1, and note this number is even. 15 plus 1 16, so number became 16. Now 16 is even, so we will replace in the third step n by 16 by 2, which is 8. Okay, this is also even. N is 8, which is even, so we will again replace n by 2, that is 4. Now 4 is also even, so we'll replace n by 4 by 2, which is 2. 2 is also even, so we will replace n by 2 by 2, which is 1. Now we have reached 1. Note, after reaching 1, what will happen? N is 1, which is odd. So what will happen is, I'm writing over here. Now n will be replaced by 3 times 1 plus 1, which is 4. Again we have reached 4. From 4 again we will reach 2. From 2 again we will reach 1. Then again 4. Then 2. Then 1. We will keep on looping over here. That's why this problem ends when you reach 1. So in how many steps from 5 did we reach to 1? We reached in 1, 2, 3, 4, 5. Yeah, till in 5 steps. In 5 steps we reached 1. Okay. Now we will see a graph which shows what happened to this algorithm if you give 25 as input. Okay, we will change the color. What happens when you give 25 as input? 25 is odd. It will be replaced by 3n plus 1, which is 76. 76 is even. It will be replaced by 76 by 2. 38 is also even. It will be reduced. That is, it will be replaced by half of it. Again, it is odd, so it will be increased to 3n plus 1. You keep on doing it. Follow the arrows. And what will happen is, what will happen, we'll see it below. What will happen finally, in after a lot of steps, you will finally reach from 8 to 4, and from 4 you will reach to 2, 2 to 1, again 4 to 1. You will keep looping over here. So this is in a graphical way. The arrows are showing after applying the rules of Collatz conjecture iterative algorithm, uh, where we are reaching. If you start at 18, in how many steps do you reach 1? After a lot of many steps, right? So what we can do is, now the question is, for any positive n, if you take any number n, will you always reach 1? This is the problem that researchers are trying to prove. Will all the numbers, positive numbers, always reach till 1? Okay. So the answer is yes. Why is that? Till now it has been not been given a formal proof, but we get a feeling, an intuition that it will reach 1. Why is that? Because whenever your number is odd, you're replacing the number by 3 times the number plus 1. And we know that 3 times any number plus an 1 is always even. So whenever your number increases, it will become even, and after becoming even it will be kept on reducing by half by half by half. Again somewhere you will get an odd number, it will shoot up and then become half half half. So it gives you a feeling that definitely you will reach 1 at some point. Okay, so now we can try to code it in Python. Let us see. Try to write a piece of code for this. In how many steps do we reach 1? Or we will always reach 1 or not? Okay. Yes. So this is a very simple algorithm, but yet this has not been proven yet till now by researchers. For any positive number, will we always reach 1 or not? Is there any number that will never reach 1? Okay, so we will write Collatz conjecture. Collatz conjecture. Okay. Oh, sorry. And we'll write the code. Okay. So let us write Collatz. Okay. Number is n. Okay. So what we will do? If we will keep doing this till our n is not equal to 1. As soon as you reach 1, we have to stop. So if our number n modulo 2, the remainder on dividing by 2 is 0, that means it is even, then we will replace n by integer 2. Because if I do only one single backslash, it will be giving you a floating value. Okay, and we will increment. There is another variable, we will say iterations. Okay, yeah, steps. We'll keep another variable known as steps as 0. Okay, and over here, after doing this, we will increment our steps. Steps is equals to steps plus 1. In how many steps we are reaching? uh, elif our number modulo 2 is equal to 1, that means it is odd, then we will replace n by 3 into n plus 1, and we will increment our steps is equals to steps plus 1, right? And then we are going to, at the end, after this while loop is over, what we are going to do is, it is not in the same line, right? Oh, okay, it is not inside the while loop. Okay, we will return steps, comma. In how many steps we are reaching the n? So we will return n and steps. Okay. So what we are doing is, we are giving an input positive number n, and how many steps we are reaching 1 we want to see. So if while n is not 1, okay, not equal to 1, what we are going to do is, if your number is even, that means on dividing by 2 it gives a remainder of 0, then we will replace n by 2 and increment our steps by 1 step. Else if what we will do, our number is odd, that means on dividing by 2, if the remainder is 1, we'll replace n with 3n plus 1 and increment our steps. and we will keep on repeating this while our n now is not becoming 1. And then what we will do at the end, uh, the same, we will return our n and steps. Okay, so what we are going to do, we will call this function Collatz. Let us check for 5. Okay, first we will check for 5. LA Collatz, and we will call it for 5. Okay, we know, we have seen it over here. For 5, what should be our steps, in how many steps we can reach is 1, 2, 3, 4, 5, 5 steps. Okay, let us see. We'll just run this. Yes, now we will check for this answer. Maybe we will check for 25. In how many steps does 25 reaches 1? In 23 steps. Okay, so hope you like this video. Please share it with your friends, subscribe to my channel, and happy coding. Keep exploring new math models. Okay, bye bye and take care.